In this lesson, we're going to use properties of logs to expand and condense logarithmic expressions. I want to remind you of your exponent properties for when we have like bases. So if I have b to the x times b to the y, because the bases are the same, we keep our base and add our exponents. So it should come as no surprise that because exponents and logs are inverses of one another, that we have a very similar product property for logs. Log base b of x times y is equal to log base b of x plus log base b of y. Our quotient property for exponents is keep our base and subtract our exponents. So when we have a division, we separate it into two using subtraction. The power property, a power to a power, we've learned keep your base and multiply your exponents. So when I have log base b of x to the p, a power to a power, what do? I bring the p out front, it becomes multiplication times log base b of x. So you're going to be using these properties in this lesson to expand and condense different logarithmic expressions, and later you'll be using these properties to help you solve logarithmic equations. In our first example, the directions say to express the logarithm in terms of 2 and 3. Well, that means I have to change 96 into 2 and 3 somehow, and it has to be equivalent. So what I suggest you do is break down 96 into a product of its primes, meaning off on the side, make a quick factor tree. 32 times 3, 4 times 8, which would split into 2 times 2, 2 times 4, and 2 times 2. So what I see here is that 96 is equivalent to 2 to the 5th times 3. So what I've done is I've replaced 96 with 2 to the 5th times 3, and now I'm going to start applying my exponent rules. Because my argument is a product, I'm going to separate this into two logs with the same base. This is our common log, base 10, and I'll have log of 2 to the 5th and log of 3. Well, now log of 2 to the 5th, I can do our power rule, which will change this into a product and bring this 5 out to the front. So I have 5 times log of 2 plus log of 3. And I now have satisfied the directions where I've changed this into logs using 2 and 3. And one of the things I suggest you do is make sure you have equivalent expressions. If you type log of 96 into your calculator and then 5 times log of 2 plus log of 3, you'll see you get the same decimal. Again, we're told to break this down into terms of log 2 and log 3. So I know that the denominator can be replaced with 3 squared, and my numerator is equivalent to 2 to the 5th power. Okay. My argument has a quotient, so I'm going to split this into 2, where I take my numerator and I subtract log of my denominator. Okay, and now I have power to a power here and here, so I am going to use my power rule, where this will turn it into a product, so be 5 log 2 minus 2 log 3. And you can see that my logs are in terms of 2 and 3. And again, toss it in your calculator and make sure your starting and ending expression are equivalent. Okay, now we've got log base 2 of the cube root of 32, and we are told to evaluate this. So when you first look at this, you're like, oh, good grief, how do I even begin to do cube root of 32? So here's what I'm going to do. I'm going to begin by doing 32, and I'm going to change this to rational exponent form. So that's equivalent to 1/3. So I have 32 to the 1/3. And then I'm going to use my power rule, and I'm going to bring this 1/3 out to the front here, and I would have 1/3 times log base 2 of 32. And now I think I can do log base 2 of 32 in my head, because think about it, what it would be in exponential form. This is saying that 2 to some power is equal to 32. Well, I believe that's 2 to the 5th is 32. So I would then have 1/3 times 2, which is 2/3. So this whole expression evaluates to just 2/3, and I never had to pick up a calculator. Okay, now I have an expression involving the natural log. So the properties that I started this lesson with apply to the natural log as well, because they just have a base e. So the first thing I'm going to do here is take my power rule and bring the 4 to the front and this 2 to the front. So I'd have 4 times 3, which would be 12 times the ln of e, minus 4 times the ln of e. And hopefully you recognize this as one of the properties. The ln of e is equal to 1, because if you remember what this is actually saying, it has the base of e. So it's saying e to what power is equal to e? Well, that's 1. So I have 12 times 1 minus 4 times 1, which is 8. Now we're going to use the properties of logs to expand each expression. So if I look at my argument here, I've got a bunch of things going on. I've got the ln of, and then I have a product. So I'm going to split this apart. I'm going to make this the ln of 4, and I'm using my product rule, plus the ln of m to the 3rd, plus the ln of n to the 5th. And now I am going to use my power rule, which, if you think about it, remember power to power is where you keep your base and you multiply your exponents. So I'm going to bring this 3 out to the front, because this is really an exponent. So 3 times the ln of m plus 5 times the ln of n, and I'm just going to bring down this ln of 4. So you're finished when you have everything expressed as the ln like of one argument, and then we just have addition and subtraction. We have no like power to power anywhere or any division left over. All right, so let's expand the next expression. I have a quotient, so I'm going to separate that first into log of the numerator, which would be 2x minus 3, and I'm going to put that into parentheses so it's clear that that is the entire argument, minus the log of the 4th root of x, but I'm immediately going to change that into a rational exponent of x to the 1/4 power. And now I have an exponent on my argument, so I'm going to rewrite this using my power rule. This would become 1/4 times log of x, and I'll just recopy this first part, log of 2x minus 3, and then it's minus 1/4 log of x. All my arguments cannot be broken down anymore, because right here this is both a product and subtraction. Like, think of it like a binomial. None of our rules would apply to this. And now I'm going to go the other direction. I'm told to condense the expressions. So I'll do one thing at a time. So I have a product times a logarithm. So this is equivalent to log base 4 of x to the 1/2 power. And I have minus. I will use my power rule, move my 3 back to the argument. So log base 4 of x minus 2 to the 3rd power. And then now I have subtraction, so I can rewrite this as log, can make this one expression log base 4 of x to the 1/2 over x minus 2 cubed. You could also rewrite the numerator as the square root of x over x minus 2 cubed. I would accept either one in that last line. One more where we will condense the expression. So I'm going to begin by using my power rule, and this would be the ln of x plus 1 to the 5th plus the ln of x to the 6th. Now we have an addition of 2 ln's, so I can use my product rule because ln has the same base, it has a base of e, so join together to become the ln of x to the 6th times x plus 1 to the 5th. And I did switch the order there, but it wouldn't matter. I just like the smaller expression first. Please reach out if you have any questions.